So today we're covering binomial expansion theorem and Pascal's triangle. What is a binomial? It's simply two terms, right? It could be 2x plus 3, that's a binomial. And we're going to expand it, like if I had the power of 5, we're going to expand it using this theorem. And what is a theorem? It's simply a truth in math that we're about to learn today. And of course, we're also going to learn about Pascal's triangle, which is essential to be able to use this theorem. So let's jump right into our first example. Simplify the binomial 2x minus 3, and let's keep it simple to the third power, all right? So what does it mean to simplify 2x to the minus 3 to the third power? Well, you got to expand it. How are you going to expand it? You're going to do a lot of distributive property, right? When you have something to the third power, what you're really saying is that you're going to take that something, that base, and multiply it with itself 3 times. So you really have 2x minus 3 times 2x minus 3 times 2x minus 3. And we should all be able to do this. We should all know how to do this. 2x times 2x is 4x squared. 2x times negative 3 is negative 6x. And then please correct me if I'm wrong because I make mistakes as well. Then I distribute the negative 3 times 2x. That's a negative 6x. And then negative 3 times negative 3, that's a positive 9. And yes, we could combine the middle terms. They're both like terms. So what we really have is a negative 12x right there with the 4x squared in the front with the plus 9 at the back. So by us distributing this binomial times that binomial, we got a quadratic trinomial. And we still need to take this quadratic trinomial and multiply it by this other binomial 2x minus 3. So bring that down, 2x minus 3 right there, just bring it down. And now we need to distribute. I would rather distribute my binomial into my bigger trinomial, and that's what I'm going to do. I'm going to distribute this first term, 2x times 4x squared, that is 8x to the third. And then we would distribute the 2x to the negative 12x, that's a negative 24, but x times x is x squared. And then 2x times 9, that's 18 with a single x. We've distributed the 2x, now we need to distribute the minus 3. So we're going to distribute minus 3 times 4x squared, that's negative 12x squared. Negative 3 times negative 12x, that's a positive 36x. And negative 3 times 9 is negative 27. And then after distributing, we need to combine like terms. So the 8x to the third, there are no other x to the thirds. So that is the first part of our answer, 8x to the third. And then we move on to combining the x squares. We have a negative 24x squared with a negative 12x squared. So if you owe 24, you owe 12, you're going to owe 36 of those x squares. And then the 18x, we could combine it with the 36x, and that will be 44. Is that right? 44? 54. 54 x's. And then we would bring down the minus 27. And dang, we are done. Did I make any mistakes? Yes. Well, we corrected them. But this was barely expanding a binomial to the third power. Could you imagine if I had a fourth power right here? I'd have to multiply this by another 2x minus 3. Or a fifth power. Like, it'd be ridiculous. Like, if you had the fifth power, you would take up your whole paper to expand the binomial 2x minus 3 to the fifth power. So what I'm going to teach you today is a shortcut, because we will have fourth, fifth, sixth powers, right? And you're going to be able to do it a lot faster than what we did right here. It's still going to take a lot of work, but it's going to be a lot faster. Check it out. We have the same exact problem, but I'm going to teach you Pascal's triangle and how to apply the binomial expansion theorem. So on your paper, go ahead and write down Pascal's triangle. And please make a triangle of ones, like as in 1, 1, 1, like that. Make a triangle of ones. Okay. Now, to create Pascal's triangle, you begin with the triangle of ones, And then you take the 1 and you add them together and you write it down here in between, but down here. Not in between, but down here. Because we're going to have a bunch of different rows. First one, second one, down here. So check it out. I'm going to add 1 plus 1. And I'm going to put a 2 right here. Right? The 1 and the 1. I add them, get the 2, and I'm going to put 1s on the outside again. 1 out here, 1 out there. And then I'm going to take my my 2 and my 1 and add those together. So 1 plus 2 is 3, and 2 plus 1 is 3, and we put 1s on the outside again. And then we add the 1 and the 3, and we get 4, put that down here. And then we add 3 and 3, get 6, put that down here. Then we add 1 and 3, get 4, put that down here. And again, we put 1s on the outside. And you continue this for as long as you want, okay? This is what Pascal's triangle is. You start out with a triangle of 1s, you add 1 plus 1, you get 2, bring that down. Put 1s on the outside again. And then 1 plus 2 is 3. 2 plus 1 is 3. Put 1s on the outside again. And then you add 1 and 3 is 4. 3 and 3 is 6. 3 and 1 is 4. Put 1s on the outside again. If I wanted the next row, what would it be? Well, I would have to add 1 and 4, and I'll get 5. I would have to add 4 and 6, and I would get 10. I'd have to add 6 and 4, and I'd get 10. And I would have to add 4 and 1, and I would get 5. And again, we put 1s on the outside. So you could continue this as long as you need to. Now, how do you know how big of a Pascal's triangle you need? Well, give me a second. So if you have anything to the 0 power, what do you get? Anything to the 0 power? Anybody? Yeah, anything to the power of 0, you're going to get 1. Now, then you have power of 1, and you're going to end up using this row. Power of 2, end up using this row. Power of 3, using this row. Power of 4, using this row. Power of 5, using this row, and so on and so on. I know this sounds really weird. Bear with me. So Pascal's triangle, you create it with your triangle of 1s, and then you find out which row you need according to your power. So this power is the power of 3, okay? So we're going to be using this row 1, 3, 3, 1, okay? Now, how do we use 1, 3, 3, 1? You simply write out 1 and then do 2 sets of parentheses. And then 3, it's a positive 3, and then 2 sets of parentheses. And then 3, and then 2 sets of parentheses, and then 1, and then 2 sets of parentheses. Okay, now, this first parenthesis, you're going to get the power of 3. The highest power, you're going to put it on the first parenthesis. So you're going to put a 3 right here, which means that this one would have to be 0, because 3 plus 0 is that 3. But then that 3 is going to drop by 1 to become 2 on the next one, and the 0 increases to become 1 on the next one. And then the 2 decreases, so the first parenthesis power continues to decrease 3, 2, 1, 0, and the second parenthesis continues to increase from 0 to 1 to 2 to 3. Okay, you guys following me with this little trick that we're doing here? This is a binomial expansion theorem. So once again, the first parenthesis, put the power on that first parenthesis. And then on the next one with that first parenthesis, drop it to 2. On the next one with the first parenthesis, drop it to 1. And on the next one with the first parenthesis, drop it to 0. Okay, maybe let me actually highlight them. So we have the power of 3, then it dropped to a power of 2, dropped to a power of 1, dropped to a power of 0. Now, on the other hand, we had the power of 0 on the second parenthesis, And that one increases as you go to the next one. It increases to 1. It's going to increase to 2, increase to 3. Okay? So we have a 2 right there and a 3 right there. And what do you think we're going to be putting inside this parenthesis and that parenthesis? Any guesses? The 2x goes in the first one, and the minus 3 goes in the second one, right? So the 2x goes right there, 2x goes right there, 2x goes right there, 2x goes right there. You put that 2x on the first one on each one, and you put the minus 3 on the second set of parentheses on each one. Minus 3, minus 3, minus 3, minus 3. Yay? Okay. So we have to actually work out each of these, right? So on this first one, 1, it's just 1 times. Who cares about that 1 times? But right here we have 2x to the third power. So we could distribute the 3, put it on the 2. That's 2 to the third. 2 to the third is really going to be 8, right? But you also distribute it to the x, and that'll be x to the third. And we know that that is an x to the third. So the 2x times itself 3 times will be 2x times 2x times 2x, which gives us the 8x to the third. Now we also know that anything to the 0 power is what? 1. So you don't even need to write it. You could just scratch it out. And this 1 out here in the front, it doesn't matter. Don't even bring it down, because 1 times 8 is still going to be 8. That's why we scratched it out, because 8 times 1 is still going to be 8. Anyways, your first term will be 8x to the third. Let's move on to our second term. And right here, we're going to begin with 2x squared. What is 2x squared? 4x squared, right? 2x times 2x is 4x squared. Or you could have distributed it to both. 2 squared is 4. X squared is x squared. Don't forget about the 3 that's out in the front. That you are going to bring down. And how about over here? What's negative 3 to the first power? What's negative 3 to the first power? Negative 3. So I still need to multiply by this blue negative 3. I might as well keep it in parentheses so we don't get confused. So we're going to multiply all the numbers, the 3 times negative 4 and then times negative 3. 3 times negative 4, why am I saying negative 4? 3 times 4 is 12, and then 12 times negative 3 is negative 36 with an x squared on it. And that's my second term of my answer, right? How about my third term? Well, we're going to start 2x to the 1. That's easy. That's just 2x. Negative 3 squared. What's negative 3 in parentheses squared? 9. So what I really have here is 3 times 2x times 9. So 3 times 2 is 6 times 9 is 54 with an x. And that's my third term. And this is a positive 54, so I'm going to put a plus sign in front of it. Now for my last term, it's pretty easy. Anything to the 0 power, 2x to the 0 power, that becomes 1. So I could just scratch that out. Negative 3 times negative 3 times negative 3, what is that? Negative 27. So negative 27 is your last term. So believe it or not, there's our answer. 8x to the third minus 36x squared plus 54x minus 27. Same problem we did, but we just used Pascal's triangle. Now, I know you might be thinking, the heck with this, man. This is kind of challenging. I would rather just multiply this with itself 3 times. But what if it were a 4 or a 5? It's really easy, a lot easier to use this one. So if you had the power of 5, you would put 1, parenthesis, 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 5, parenthesis, 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 10. And you just do 2 sets of parentheses after each one of these. And then in the first set, you plug in the 2x. In the second, or in the first parenthesis, you plug in the 2x. The second parenthesis, you plug in negative 3. And you start with the highest exponent on your first parenthesis, and it continues to decrease by 1 as you go to the next ones, and 0 on the second parenthesis, and it continues to increase by 1 on the second ones until you completely switch from a 3-0 to a 0-3. It sounds like a lot, but the more you practice, the easier it gets. Are there other applications for this? Yeah, check this out. If I said, find the fourth term of this, right? We don't want the whole answer, but let's find the fourth term. Okay, well, if we want the fourth term and we know it's to the power of 6. Well, let's first start by doing Pascal's triangle of ones, and then you go 2, 1's on the outside, 3 right there, 3 right there, 1's on the outside. Again, how am I doing this? I'm simply adding. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 1 is 3. Bring down 1's on the outside. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Put 1's on the outside. So there it is. 4, 6, 4, 1's on the outside. Add 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 1 plus 4 is 5. 1's on the outside. And let's think, what powers do we have here? You always start with the power of 0. That always gives you 1. Then you start power of 1. Use those. Power of 2. Use those. Power of 3. Use those. Power of 4. Use those. Power of 5. Use those. Dang, we still need the power of 6. So we need to go even one row further. So we're going to add 1 plus 5. That'll give us 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 1 plus 5 is 6 with 1's on the outside. And that would be the row that you want. So we're going to start by doing 1, parenthesis, 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 plus 6, parenthesis, 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 plus 15, parenthesis, 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 parenthesis. And keep in mind, we want the 4th term. So here's my 1st, 2nd, 3rd. The next one is my 4th one, which would be this one with the 20. So plus 20, parenthesis, 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 parenthesis. Okay? So if we only want the 4th term, we could just ignore this, and you don't even have to worry about the rest. We could just work on that one. Oh, I'm sorry. Maybe I shouldn't have scratched them out. Because if it was the 6th power, you would need to know that this first parenthesis has the power of 6, and then it drops to 5, then it drops to 4, then on this, the term that we actually want, it drops to 3, correct? And the second parenthesis, it should have started with 0, and then it increases to 1, increases to 2, increases to 3. So I don't have to worry about anything else before this or after this. They only want the 4th term, so we just need to figure this out. So what goes in the first parenthesis? What goes right here? 2x, right? 2x. What goes in the second parenthesis? The 3, right? So put the 3 right there. So all we got to do is focus in on this guy right here. On the 20 times 2x to the 3rd times 3 to the 3rd. So doing the math, we're going to go with the exponents first. Put the 3 on the 2, put the 3 on the x. That'd be 2 to the 3rd, x to the 3rd. That's really a 8x to the 3rd. And don't forget to bring down the multiplication of 20 right in front of it. And we all should know that 3 to the 3rd, 3 times 3 is 9, times 3 is 27. So we're going to do this with the calculator. So we're going to end up with 4,320. 4,320. That's 20 times 8 times 27. And don't forget about the x to the 3rd. So this is your 4th term of this. So there will be questions on the quiz, and I think on the final exam as well, where I give you a binomial to a certain power, and I ask for a certain term. Maybe the 1st term, maybe the 4th, maybe the 5th, right? And this is the 4th term. There will be some where I actually ask you to expand it and give me the whole expanded form. But that does take a lot longer. What do you guys think? So I'm going to stop recording now, but you guys do have an assignment on Google Classroom that you could continue to practice with.